Part B for Unit 2 exam review. So here are the answers. Okay, so the first question was talking about inhibitory postsynaptic potentials, or IPSPs, and they lead to which response? That would be hyperpolarization. Okay, so in this area of Chapter 3, I want you to go back, review IPSPs, EPSPs, depolarization, hyperpolarization, how they occur, like what's going on with that sodium-potassium pump, and then also that resting membrane potential that's a -70, and that the sodium-potassium pump's maintenance this -70 unless the stimulus comes in and that we need a depolarization or hyperpolarization. So if depolarization, we open those sodium channels, they flood in, we're getting that cell more positive. If it's hyperpolarization, we're going to open potassium doors, those channels, they're going to come out, we're going to have that cell become more negative, so we're going to inhibit that response. I also want you to go back and review over graded potential and then action potentials as well. And that is pretty, and also, before I forget, absolute and relative refractory periods. I want you to go back and know the definition of those two, that the absolute refractory period is that point where the sodium channel doors are already wide open, so if another stimulus were to come in, the cell's not going to respond to it. It's already at its max, the doors are open, it's already depolarized and nothing else is going to occur from it. Now, if we're in relative refractory period, so sodium channel doors are closed, we're kind of in that repolarization phase where we have the potassium. Now, because of there, we're kind of in there, depending on how strong that stimulus is coming back in, the cell may be able to respond to it and open back up those sodium doors again, those channels to flood back into the cell. So it just all depends on the strength. But in relative, may have a response, absolute will not occur. So go back and review that out of Chapter 3. Now, the next statement was talking about your RER values approaching that numerical value of 1. So when we're looking at this, we're looking at that ratio of that rate of consumption for O2 over that consumption of CO2. It's going to give us an estimate that it's going to let us know a good high probability that if it's at 1, that glucose/glycogen is going to be the primary substrate that's going to be used maximally at this intensity. And then go also look at that 0.7, that means fat metabolism. And then I want you to also go and look what our RER would be if we're at rest. Okay, what numerical value would that be as well? Now, carbohydrate oxidation yields more ATP per molecule of oxygen consumed when compared to ATP yield per oxygen molecules consumed. And that's because it takes so much oxygen for fat metabolism than glucose metabolism. So in comparison, we yield more ATP to oxygen consumed in comparison, even though we have more ATP made with fat metabolism, it also requires more consumption of oxygen. So in comparison, we don't yield as many to O2 consumption in comparison to glucose. We yield more in consumption to oxygen. So that's what it's comparing right there. Okay, so the next one that we are going to be looking at is T3 and T4. These are the hormones the thyroid produce, and we're looking at the functions here that it's responsible for. And the one that you should have chosen that it is not responsible for is inhibiting protein synthesis. T3, T4 actually increase protein synthesis. So I want you to go back, review these hormones. I also want you to focus on insulin, glucagon, growth hormone, your catecholamines, epinephrine, norepinephrine. Look at their functions and also their response to exercise, because you'll need to know those things for your exam. Okay, so EPOC, when we're in EPOC, this is when we stop the exercise, we have this higher respiration, we get down with this, and this recovery time, this period, there's certain things that are occurring for the body to get back to homeostasis. The one that you should have chosen, though, because it's asking what it is not doing during EPOC, and that would be replenishing NAD storage in mitochondria. We're not doing that during EPOC. We are restoring oxygen stores in our hemo and myoglobin. We are replenishing our cytosolic ATP and our PCR storage, and then we also are replenishing our glycogen storage via lactate conversion during this time. So we're kind of getting everything back in order. And then also we have, that's also occurring, we're getting rid of that excess CO2 that's a byproduct that we made during that exercise. Now, when we look at submaximal exercise intensity, and as it increases, the rate of consumption of oxygen increases proportionally, so that VO2 increases proportionally to the intensity increases in that submaximal exercise. Okay, the next one was talking about if you were having, or if you see someone that's having trouble passing a roadside sobriety test, if they're not able to walk that line, they're having trouble touching the finger to the nose, what area of the brain is affected, and that would be your cerebellum. Okay, that would be the area, if we had alcohol consumption, that affects that area of the brain. And that's the reason why we have that lack of gross motor coordination. What I want you to do is go back and review that, your dephrocephalon, your diencephalon, midbrain, medulla oblongata, your primary motor cortex. Review all those areas and what they're responsible for. Also, what I want you to go back and review are your receptors. It talked about, in your book, chemoreceptors, thermoreceptors, all of those receptors I want you to review and what they respond to, like what stimulus they respond to. And then also your joint kinesthetic receptors, muscle spindles. Now this next one was in reference in particular to your Golgi tendon organs. If they were to be activated, they are being activated to keep the muscle from contracting too forcefully. So they're going to decrease agonist response and they're going to increase an antagonist muscle response, and it's to mainly keep control there so that prime mover is not producing too much force to hurt the muscle. Let's see. The next one is talking about, even after training or continual training, that everyone reaches a VO2 max plateau. But even though we've reached this plateau, that we have seen with training that performance can still be improved. And what attribute contributes to this? And that would be that continual improvement or increases in the lactate threshold. So we know that even though we may plateau our VO2 max, we can continually train to improve our lactate threshold, and by this improvement, which is a percentage of our VO2 max, that crosses over an improvement in performance. Okay, so the next one was asking about the region of the nerve cell and then what area this nerve cell that integrates the IPSPs and EPSPs. And you have the dendrites, the cell body, the axon hillock, the axon, and then axon terminals. It would be the axon hillock is the part of the cell body that, or the nerve cell, I should say, that integrates the summation of these potentials coming in. Okay. We have that, and the next one is a part of our fatigue. It talks about our metabolic byproduct. I want you to go back and review over the causes of fatigue. Go and review about DOMS. I want you to review over that as well. When we talk about this one in particular, we're talking about acidosis within the cell. Even though we're doing buffering to maintain cell life, because the cell still is too acidic, it can hinder function of the cell. So the cell may survive, but it's not going to be able to function accordingly. So if the pH drops to 6.9, it's going to inhibit ATP synthesis. And then if the cell goes even further to 6.4, altogether we're not going to be able to break down glycogen anymore. The cell will maintain life, but with it being so acidic at that 6.9 and that 6.4, it's going to inhibit those functions at those levels. So make sure you go back and review that as well. I also want you to make sure you review closely your parasympathetic and sympathetic systems. I want you, this is going to be in relevance to your essay question. Go back and look at the function. Parasympathetic system is responsible for what? Your sympathetic system as well. And I want you to be able to, this essay in particular is going to have you compare them, because even though they're antagonistic to each other, they still have to function cohesively together, especially in the significance of response and when we are performing physical activity. So I want you to be able to tell me about them, and then also I want you to tell me, even though they're antagonists, I keep saying that word wrong, even though they're antagonistic to each other, about how they work cohesively together as well. Basically, they're the yin and yang to each other. Explain that to me in your essay question. I believe this is pretty, there's other areas that you need to know. I think I've told you to make sure that you study with the anaerobic tests that are used to quantify anaerobic capacity. I think that's pretty much it. And just go back and re-look over. It's always good to look at those study questions at the end of your chapter, and of course review over your essay questions that you submitted to for each of these chapters, and then you should be pretty good and do well on this exam. The exam will open up this Friday at 8 a.m. and then it will close Sunday at 10 p.m. If you have any questions or concerns, make sure that you email me. And if you have any problems with the exam, if it shuts off on you for any reason, you have to email me immediately and I'll reopen that exam for you. All right, I think that's it. Good luck, and just let me know if you need anything.